Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, I will go over the product rule. But before we do that, we are actually going to practice using our first four rules. Let's recall what they are. They are the power rule, which is the derivative of x to the n is equal to n times x to the n minus 1. And this is proven using the binomial theorem. And the constant rule, and that is simply just d dx, or the derivative of k is equal to 0, and this is just by looking at graphs and proving it using the definition of derivatives. And similar thing with constant multiple rule. And that is the derivative of some constant times a function is equal to the constant times the derivative of that function. And the last rule is the sum and difference rule. And that would just be the derivative of this fx plus or minus g of x. We can just separate them to be f prime of x plus or minus g prime of x. So using these four rules, let's see if you can solve this problem. Find f prime of x, or the derivative of f of x. And pause the video if you want to take a try, and proceed the video when you're done. So first step, let's break it up using our sum and difference rule. So that would just be f prime of x is equal to this d dx of x to the fifth plus d dx x to the fourth plus this root 2. So d dx root 2 x cubed plus d dx 3 to the 7th x squared plus d dx of pi. And that is actually equal to, so we can use the power rule here, so that would just equal to 5x fourth plus 4x cubed plus this root 2. We can use the constant multiple rule just to get it out, because even if it is root 2, it is still a constant, it's still a k. And even if we have like some sort of ugly numbers, as long as it doesn't include this variable, even if it includes some other constant variables, it can still be getting out. If it is root 2, then you just get it out using the constant multiple rule, and that will be times the derivative of x cubed. And well, that we can just further simplify using the power rule. So that's just 3x squared plus this 3 to the 7th. Just like I said, it's still a constant multiple, so we can just write it out, 3 to the 7th. We don't need to do any manipulation. This is not the power rule, alright? And that's just times 2x using the power rule. Then the other part is the power rule, because the other part does contain x. So that would be this term, and the last term is pi. Don't get shocked if it's an irrational number. It is still equal to 0 by our constant rule, so it's still 0. Now let's simplify even more. So that's 5x fourth plus 4x cubed plus 3x squared root 2 plus, that's 3 to the 7th. I mean, you can leave it like this, but if you don't like to leave it like this, you can do some sort of calculation to calculate it out. So I will just calculate it out. That's 4374x, and plus 0 is just 0. So we're done for our problem. Not that bad, right? Now let's get back to today's topic. Today's topic is the product rule. So in the product rule, as you might have known, the product rule is trying to calculate the derivative of the ddx of fx gx. So two different functions. Let's get an intuitive sense of it. If we have this, then let's say we can use the linear function as an example. We don't have to use linear functions to use the product rule, as I will prove the general case later, but the linear function is the easiest to deal with. So for example, if we have let's see, we have a linear function like this. If let's say we can get a quadratic in there as well, we don't mind that. That would be a quadratic. So that's a quadratic, that's a linear. Let's say this is equal to y is equal to x, although it's not super accurate. And this is equal to y is equal to x squared. Let's try to find the proof of both of them. If we multiply these two functions, then we get y is equal to x cubed. Over here it gets kind of confusing which y we are referring to, so this would be better written as f of x and g of x. And if we multiply that, then we just simply have f of x times g of x is equal to x cubed, which looks something like this. Just like this. And if we have that, then let's calculate the derivative of both these initial functions. So if this initial function, that's easy, that's just 1. And this one, g prime of x, that's just 2x using the power rule. And we can find the derivative of this as well. F of x and g of x. That is 3x squared. Obviously, they're not just straight up multiples of each other, because that's not gonna work. Let's see what we can do to get that. So first of all, we need the x squared term like somewhere, right? We just cannot have x squared terms if we just multiply these. And obviously, we have an x squared term here. How do we prove that? If we have x squared term and it's the product, then we'd think that we want to multiply it by something. Then multiplying it by what? Well, the only constant over here would just simply be this. So x squared and 1. Actually, let me use the same color. X squared and 1. And this is 2x and x, because they're symmetrical. So if these two multiply, then these two also multiply. So this is just our hypothesis over here, that this is equal to the value of f of x g prime of x plus f prime of x g of x. Let's actually try to prove it now. So what we are trying to prove is that we actually want to prove this is equal to that. So if we take the derivative of that, obviously we're still using the definition, and it's second to the last rule that we're actually using the definition of derivatives. So this is the limit as h approaches 0 of this whole thing. So f of x plus h, g of x plus h minus f of x plus h, g of x plus f of x plus h, g of x. Because if you just see this as a function, you can do this. And this is basically just the definition. F of x times g of x over h, of course. And if we have that, then we can do the limit as h approaches 0, that this whole thing. Let's pick up something. Let's see. This and this has a common factor, and this also have a common factor. So that would just be the limit as h approaches 0 of this all over h thing, and the numerator would just be f of x plus h times this g of x plus h minus g of x plus this g of x thing, so plus g of x times f of x plus h minus f of x. And obviously at this point you might recognize these kind of things, but we can use the property of limits. So that will be f of, technically this is the limit of f of x plus h. However, as h approaches 0, and this f is defined, so this part just can be ignored. So that would just simply be f of x times this limit as h approaches 0 of g of x plus h minus g of x over h plus, so that will be plus this g of x, so that would just be g of x times the limit as h approaches 0 of f of x plus h minus f of x over h. And obviously these, as you can recognize, are just simply the definition of limits. And we are almost done, so that's f of x times g prime of x plus g of x times f prime of x, which is exactly our hypothesis. Thank you for watching this episode of Investigation, and I will see you in the next one. Sorry that my microphone actually died yesterday and I couldn't get it fixed in time, so that's a 1 day late upload.